This video is about regression analysis. A regression describes the functional relationship between two continuous variables, where one variable can be predicted from the other. And there are many types of regressions. They can be simple. We only have one independent variable that predicts one dependent variable. It can also be multiple, where we have several independent variables in two or more dimensions that predict one response variable. Regressions can be linear, then the material is described by a straight line, or it can be nonlinear, and then the material is described by some other function. In this section, we're going to focus on simple linear regressions. And we will work with a dataset consisting of two variables: morning temperature and kilograms of sold ice cream during the day. Imagine that you own a beach stall selling ice cream, and you want to predict how much ice cream you're likely to sell each day. You don't want to bring too much ice cream to the beach and risk that it goes bad, and you certainly don't want to bring too little ice cream and lose possible income. So it's likely that the temperature during the day will affect how much ice cream you sell. Warmer days, more ice cream sold. So here we record data of morning temperature and kilograms of sold ice cream for 5 days. The independent variable will be temperature, and the dependent variable, the response variable, will be amount of sold ice cream. Let's plot the data. Here it does look like the amount of ice cream sold is affected by morning temperature and that this relationship is linear. But how do we describe this relationship? How do we predict how much ice cream we will sell at a specific temperature? To predict the amount of sold ice cream, we will use the regression equation. In the regression equation, x is the independent variable, that is temperature in our case. Y is the dependent variable, kilograms of sold ice cream. Alpha is the y-intercept, the value of y when x is 0. And beta is the regression coefficient, or the slope, that is how much y changes when x increases with 1 unit. If the regression coefficient, beta, is positive, y will increase when x increases, as it looks like in our case. If the regression coefficient is negative, y would decrease when x increases. And if the regression coefficient is 0, there will be no change in y when x increases. This equation describes a population, but as usual, we have a sample and we have to estimate the population's equation using the data from our sample. The sample's equation is written in lowercase. We now need to estimate alpha and beta, or A and B. And we do this by using the following equations. So let's start with B. We need a number of calculations to get to B. First of all, we're going to need the means of x and y. That is simply the average of our data, x and y. We're also going to need delta x and delta y. That is the difference for each data point to the mean. Delta x we have in this column, delta y we have in this column. We're also going to need to multiply these differences, delta x times delta y, which we have in this column. And we're going to need to square delta x values. We have that in this column. In the denominator of the equation, we have the sum of the multiplied differences. that is the sum of these values. That is 299. And then the denominator, we have the sum of the squared delta x values, these values. That is 140. So now we have all the numbers we need to calculate b. The sum of the multiplied differences is 299 divided by the sum of delta x squared, which is 140. And this gives us a value of 2.14 for b. Now let's move on to a. To calculate a, we need the mean of y and x, and we need b that we just calculated. This gives us the average of y, which is 53.8, minus 2.14, or b, times the average of x, which is 15. And this will give us an a of 21.76. Thus, our regression equation is y equals a 21.76 plus b 2.14x. And this means that with each degree increase in temperature, the ice cream sales will be up 2.14 kilos. And when x is 0, we can expect y to be 21.76. However, you should always be cautious about extrapolating outside your data points. We actually don't know how temperature affects ice cream sales outside this measured range. It might not be a linear relationship at all at 0 degrees. When we have the regression equation, we can use that to make a prediction. So let's say that the morning temperature is 10 degrees Celsius. How much ice cream can we expect to sell that day? We use our regression equation. We put in an x, a temperature of 10. And we calculate a y, which is 43. This means that if the morning temperature is 10 degrees, we can expect to sell 43 kilograms of ice cream that day.